So a warm welcome to everyone that is joining our panel discussion, Insights into Autism Research with Eye Tracking, and a super warm welcome also to our fantastic panel today, Monica Sequeres from Stanford School of Medicine, Maja Rydling from Uppsala University, and Ana Maria Portugal from Karolinska Institute and Uppsala University, representing both institutions. And I'm Shida Ackerman from Tobii. I am a global manager for education services, and I have myself worked in academia with eye tracking and autism research. So that's why I'm part of this panel discussion. Let's start. I thought we give a bit of an introduction first into the topic, ask you some questions. We want to know who you are, the audience, and we want this this event to be an active, interactive discussion. So feel free to ask us questions. It is nice to hear from you, to hear what you are doing in your research and how you want to integrate eye tracking in your research. Also to hear about your experience with autism research and what eye tracking is adding to that. Let's start with a poll to get to know each other a little bit. So let me see if I can do that. I'm trying to launch a poll now. This should open up now for you. So have you used eye tracking in your research? Or see some answers coming in. Wait a little bit longer to see what we get here. People are still answering. Okay, I see answers are still coming. Okay, almost 90% that have answered, so let's close this one. And we share the results. All right, I hope you can see the results now. So fantastic to hear that 50% of you are actually currently using eye tracking in your research. So that's great. I'm super excited to hear your thoughts on that. And we have 32% that have used eye tracking in the past and 18% that have not used eye tracking. So also a warm welcome to you. We hope that inspire you to use eye tracking soon in your research. But let's start with some background about eye tracking and also making the link to autism. So I will have a very, very short presentation about that, and then I will open up for questions. We have prepared a few questions for our panel, but as I said before, feel free to ask questions. You can see in this window from GoToWebinar that you can write your questions. I think it should open on the right-hand side on your screen, and there you can ask your questions. So, but let's start. Our eyes are super important in our everyday life. Oh, I have not hidden the poll. All right, good, great. Still learning how to use. Okay, but let's go on. So our eyes are super important in everyday life. Understanding how we use our eyes in different contexts is important for our opportunity to learn and interact with the world. When in a new situation or hearing a strange noise, my one-year-old would often look at me and try to read my reaction to a strange environment. Have I changed my facial expression, or am I scared of the changes in our environment? Or do I remain calm and we can continue to play? We are making sense of the world through our eyes. The eye tracking allows us to measure how we are looking at the world around us, and it can serve us to address a wide range of scientific questions. Eye tracking has been frequently used in the field of autism, but why has this methodology become so important in autism research? So it is assumed that where neurotypical individuals choose to pay attention to may be different than autistic individuals when it comes to socially relevant information and face processing. About 20 years ago, an early eye tracking study suggested that autistic individuals show different gaze patterns when looking at photographs of facial expressions compared to controls. The study found that they spend a smaller fraction of time looking at the nose and eyes than controls did. In another study, adults were shown scenes from the movie Who's Afraid of Virginia Woolf? The researchers found that autistic individuals showed different gaze patterns there too. They would prefer looking at the actor's mouth or even at movements far in the periphery of the scene, as opposed to watching the actor's eye. So when going back to my 1-year-old, if she's not aware of the richness of information that she can get from my eyes and facial expressions, she may be inhibited in her learning and development and how she is making sense of the world. Another interesting area of research, especially for autism, is assessing theory of mind. So the ability to understand others' beliefs and intentions, which can be assessed with eye tracking. Researchers also use eye tracking to monitor other measures, such as the blink rate. There are studies suggesting differences in how often autistic versus typically developing toddlers blink when watching emotional scenes. And there is research showing that autistic individuals do not synchronize their eye blinks with those of other people as much as neurotypical individuals do. Some scientists also see the pupil as a potential window into autism. For example, there is research showing that the pupils of babies later diagnosed with autism shrink more in response to light than those of typically developing babies. Such findings may help researchers identify biological pathways involved in autism. It can also be used as a component integrated into other technologies, such as virtual reality systems to train social skills. And finally, eye tracking is especially useful for autism research because it can be used on young infants and children. This might allow researchers to develop biomarkers to diagnose autism at a young age, when early interventions are thought to be most beneficial. So this as a short introduction into autism and eye tracking and why this is so important and why we are here today. Let's start another poll to get to know our audience. So I'm launching this now. Do you work in the field of autism, or are you interested in autism research? Let's hear. Okay, let's see answers coming in. Okay, let's wait a few more seconds. Okay, let me see if I can share the results now. So we have a really good difference here. 54% say yes, they do work in the field of autism, and 46% not. So it's fantastic to get so much interest in autism research from an audience that is not working with autism. So that's fantastic to hear. And as we're in it with the polls, let's launch a third one. So if you work in the field of autism, what is the population that you are working with? Infants and children, or is it adults? Okay. Still collecting responses. All right, I'm closing this poll, and the majority of you are working with infants and children, and that is also the background of this panel. So we have chosen the right panel for you, but let's not forget about autistic adults as well, which is a super important topic. All right. This group. So let's open up and welcome our panel. I sharing my screen now, so you can see our panel better. Okay. All right then. Good. So let's start with just introducing ourselves a bit more and introduce your research for the audience. Maybe each of you 1 or 2 minutes so that we all have an idea what your research is about. Monica, do you want to start?
All right. So hi, everyone. My name is Monica Siqueiros. I'm currently at the Stanford University. My research has been following autism for a while. During my PhD, I did a lot of eye tracking. I focused mostly on children and infants and as using eye tracking metrics as a potential biomarker for ASD in combination with twin studies. Now in my current research, I am actually not using eye tracking, but I am still looking into autism, but mostly in the context of rare genetic disorders, such as neurofibromatosis 1, and combining it with imaging research, like MRI research.
Great, thank you, Monica. Super interesting. Let's go over to Anna Maria.
Hey, so I'm Anna. I am now at Uppsala University and also affiliated to the Neurodevelopmental Center of the Karolinska Institute. And I've done my PhD before in London at the Center for Brain and Cognitive Development, where I learned about eye tracking and I started doing infant and child studies. Sometimes in the field of autism and sometimes not. I think my research mainly focused on what can explain attention behaviors and perception and cognitive control very early in life. And I have done it through a more like individual susceptibility perspective, such as genetics, where I used twin studies and also molecular studies to explain these behaviors. But also from another perspective, I look at it as well as looking at how society and environment influence these behaviors, because I did my PhD on how technologies such as tablets and smartphones might explain or impact attention behaviors. So I've tried to put both perspectives into how attention and eye movements work in infancy.
Mm-hmm. Great. And over to you, Maya.
Yeah, hi everyone. I'm Maya Rudling, and I'm currently finishing my PhD in psychology at Uppsala University. And during my PhD, I've been using eye tracking quite a lot. So the research is focusing on early development of autism, early biomarkers, but also pragmatic language a bit, because I'm a speech pathologist from the beginning, so I'm very interested in language and how language recognition and perception is kind of interacting in development. And I've been using eye tracking both for pupillometry and for like measuring gaze patterns, but also in a live eye tracking session. Yeah, I guess that's it.
Thank you. Yeah, that's great. It seems like we have a great mix, adding also like imaging on top of that and other systems, and also Maya, you with the language approach that is also very common in autism. I think that's the way to go. Maybe Anna, what do you think is eye tracking adding to your research? So how does eye tracking bring your research to the next level?
So I've actually, I don't think I have done research in infants that didn't involve eye tracking. So it's difficult to answer that question. I think it's kind of transversal to all the research that I did since I started my PhD. And I think it's a great way to get like behavioral answers from infants and children. And I mean, infants and children, but also people that don't express themselves in a way that adults, typical adults do. So like many nonverbal participants from clinical populations also benefit from these technologies. And the way that I usually used to explain to the general public about what eye tracking was to kind of give them the idea that, you know, like infants don't reply to questionnaires. They don't even press keys on a keyboard to answer the games and tasks and puzzles that are standard in the adult psychological research. So the way that we can get answers from them is to try and, you know, play some scenes or play some games that are fun and attractive and capture where they look according to those games. That's a great way to understand their, you know, what they are perceiving, what they are learning, what they are memorizing. You can get a lot of different behaviors.
Yeah, yeah, I totally agree with you. And it really shows. I mean, we have all of us four, we have worked with infants and children, and we see it also reflected in the audience. Many of you also using eye tracking or doing research with infants and children, because eye tracking, we're able to do our research with eye tracking, and also if we're thinking of nonverbal populations. We can actually get some answers, some questions answered. Monica, do you have anything to add to that?
Well, I think a lot of my research was very much in line with Ana Maria's. I totally agree with that. It's a great way to get access to kind of what's going on in terms of cognitive processes in nonverbal populations, prior language acquisition, or other areas that don't have that command yet. I also want to highlight, and this is something that has come to me after kind of transitioning a little bit into imaging, is how non-invasive remote eye tracking is. And that is, I mean, obviously, especially for those who have been using eye tracking in the past, we know that it didn't used to be this way. It used to be very invasive, and I can't even imagine trying to do infant or child research. I've actually see kind of how it's for us. I think I'm at least familiar with the systems that they used at KI and Uppsala, since I was at KI myself at Karolinska, and they're quite good, and they're also very, you know, within reason, very easy to use with infants once you manage expectations. But yeah, that is now that I work with imaging, it's a lot more that you have to take into account, especially with sensory populations, or especially, I mean, I'm not saying it's immune to movement, but it's certainly more manageable for the participant engaging with the technology. And that obviously facilitates to a certain extent the amount of data you're able to obtain. So those are kind of my practical 2 cents.
Yeah, that's a great point. Yeah, like that it's non-invasive makes it much more like accessible also for those populations, and relatively easy to start using. Maybe, Maya, do you have like some tips and tricks for people that would like to start out with eye tracking? We said like it non-invasive, allows some head movement, so that's why we like to use it with infants and children. Do you have any recommendations for everyone that is new to eye tracking?
Yeah, well, I'm agreeing with everything that both Anna and Monica said, that it is in many ways quite easy, and it's of course very non-invasive, and that makes it a very good option for infant and child studies. But I think also, while it can look quite easy on paper, once you've done all the pre-processing, once you've analyzed everything, there's a lot of decisions that goes into doing eye tracking research. So I think being prepared for that, to define what a saccade is, what a fixation is, what exactly, which questions you're answering or asking, and how eye tracking can provide help provide answers for that is very important. I mean, that's important in all research, but I think eye tracking can look deceivingly easy, but it's still, you know, you still need to interpret the data. And I think also just continuously plotting the raw data, looking at the data, looking at what the child or what the participant is actually doing is very important.
Yeah, I totally agree with you. It can look so easy, but then you get this data set that is overwhelming, and you don't know what to get out of it and how to tackle that. So yeah, I think that's a really good reminder to invest time early and be well prepared, and also monitor like all the data collection. It could also be a drift in your study protocol that you don't notice. Could be changes in the light or study environment, should keep track of. Anna Maria, do you have anything to add to that? Like any tips and tricks?
Yeah, I guess a lot in line with what Maya said. It's like you have to think in advance what is actually it's your question and what behavior you want from that the eye tracking will give you. Is it a kind of a behavioral response, or is more like a fixation or oculomotor timings, or is it pupil? That will impact a lot what kind of task and what kind of presentation you are going to give to your participants. So planning in advance that protocol and how long and how attractive and boring it is, it's very important to get your data in the best shape possible. And I think my personal experience is that try and make if it is infants, try and make your protocol as much contingent on the baby as possible. So there are ways to make the eye tracking work for you, in a sense that it will only proceed into a protocol if the baby looks at a certain place in your screen, for example, or it will stop your protocol if the infant looks away. And those kind of technologies and methods will help you get the best data as possible and to attract the infant as well a bit more to the screen or to your setup. So yeah, having like gaze contingent approaches embedded with your eye tracker is a really smart way to get the best data as possible.
Yeah, that's a great. I see that some questions are coming in. So let's see if we can answer them. Okay, we have Gaetano who's asking if eye tracking can be utilized to determine brain impairments from certain meds, drugs, or in general. Maybe do you have like a specific? Let's see if we can get in touch with Gaetano. If you have some like a specific brain impairment you're looking at in your research, so we could answer that in a better way. Monica, as you're doing imaging, what would you?
Well, first I will say that it's kind of tricky to get an eye tracker in the scanner. It can be done, but it's under very specific circumstances, and obviously with very high requirements, since obviously we cannot get anything in the magnetic chamber that is magnetic. So it can be done. Do not be deterred. It can be done. But I think there might be, in some ways, maybe some kind of like, I don't know if you're thinking about stroke or kind of that situation, but I have never used it like that myself. So I would be a bit cautious into giving an before giving an answer.
Yeah, I agree. Maybe we should, maybe Gaetan could explain a bit more what he's doing, so we can give a better answer to that question. But let's go on to the next question. Melanie is asking, do you have any recommendations related to eye tracking for a dissertation? I would like to conduct an eye tracking study on children with reading difficulties. Oh, now I'm jumping here. Especially dyslexia. Maybe Maya, you would be the one answering that. Do you have anything you could throw out right now, or do you want to get in touch with Melanie after this panel and recommend her some literature?
Well, sure, you can contact me. I would. It's a very interesting topic, reading and dyslexia, and it's been quite a lot of eye tracking research within that field of research on reading and on small differences in reading patterns. And I think eye tracking is kind of good for that, because we can have we can see differences in very small time, very small time differences, or in very small time scales is what I'm trying to say. Get in touch and we can discuss that. I don't know if I have some good recommendations for using it in a dissertation, but why not? It's eye tracking is a good. You can collect quite a lot of data because it's quick and quite easy if you compare it to many other kinds of experimental settings, I guess. So I think it would be a very good idea.
I guess it would also, I'm just throwing in my bit, like good to look at the kind of eye tracker you have access to in terms of precision, that you can actually capture the fine movements that you will be looking into. If it's reading behavior, it needs to be quite sensitive. But obviously, Maya, do interject, please.
No, that's a very good point. Yeah. And I guess it depends also on the question you're asking, of course.
Yeah, absolutely.
All right, great. Melanie, I hope this answered your question. Feel free to reach out to Maya after this event. All right, let's go on with the questions. Get a question from Kyung Min An. If any of us has used wearable eye trackers?
I guess only in Sheila's, like Tobii office a long time ago. But I don't want to say more since this was a while and the technology moves fast. So Sheila, maybe you can update us.
Yeah, and I mean, as we all have worked or are working with infants and children, it makes it a bit more tricky to use wearable eye trackers. So the populations, for example, that I have worked with, there were up to 18 months, and there we cannot use eye tracking glasses for now, at least. We'll see what is in development and everything. But so from Tobii, we recommend to use wearable eye trackers from about 5 years old. I think there are some studies out there that have used wearable eye trackers with children in about this age range.
Yeah, but another option is to use the tracker without the screen, right? So you can still have
exactly. Yes. Yeah. Great point, Anna Maria. Yes. So I think well, Maya and I have certainly used that one, using the scene setup as we call it, without so it allows a for a more natural interaction. That works very well with infants. I've done many puppet theaters for babies. All right, it's great that we get so many questions. I see Oh yeah, Kyung Minan is also asking if participants feel comfortable with the wearable eye tracker. As far as I know, it works well in the older populations, at least. Of course, when you introduce like a device onto someone, it feels a bit weird in the beginning. But the new generation of eye tracking glasses are very natural to wear, and you will forget about it in when the study is ongoing. So the answers that we get here are often that it feels natural to interact with the wearable eye tracker as well. So I hope that answers your question. Let's go on to the next one. Okay, Nasmul, we get a question from you here. You have selected your topic to leverage ICT for children with ASD to improve their lifestyle. This is a bit jumping for me now. I'm sorry. I have to scroll down to the answer to the question here. So you're at the initial stage of your research, and eye tracking devices are not available. Is there any possibility that Tobii can extend support to sort of research here? Yes, and we're also available in India, where you are from, Nasmul. So we're happy to get in touch with you after the panel discussion. So I will get back to you. Great. Then Meghna is asking how attention plays a role in eye tracking for cognitive processes. Anna Maria, do you want to add something here?
Can you repeat the question?
Yeah, how attention plays a role in eye tracking for cognitive processes. Meghna, if you want to specify your answer, please feel free to write something more. Otherwise, you can also just elaborate on attention and how it is important in tracking research.
So attention is very linked to eye movements. So what you capture through tracking where someone looks will tell you where they are attending to and what was their focus and selection of attention. And that's, that's how, in simple terms, that's how far it will go. Then obviously what someone processes and encodes and memorizes, it's out of scope of where they look, right? But you can, a lot of studies have tried to assess those attention behaviors and how they are linked with eye movements. And what have been showed is that, they are pretty much, they are very much linked. And actually in a natural environment, in our day-to-day interactions and reactions, where we usually look is what we are processing and encoding for further memory. So I think that's what I can elaborate on. But you can be more specific if you want any other details.
Yes. So Meghna, if you have anything to add, feel free to write something more. But I think that was already a really good answer, Anna Maria. Right, we go on to Rakesh. How can Tobii help to set up pilots in eye tracking? So I'm heading up the education services team here at Tobii, and we're helping with any kinds of education and services that is related to like starting your eye tracking research, how to set up your pilot. We provide trainings. We have fantastic research scientists in all kind of different regions. So it depends on where you live. We have the right research scientist for you that can help you with your pilot study. So I'm happy to get in touch with you, Rakesh, after our event, and we can check what kind of services will be a good fit for you. Great. Then Kirill has a question for Monica. He says it's a bit off topic, but when talking about getting an eye tracker into the scanner, could you share your best practices in a word or two? In a word or
well, in a word or two. All right. Well, actually, I think the most important thing is to, I'm already over to words, I'm sorry, Kirill, but to get in touch with your MR safety technicians. They're the most knowledgeable. They will know exactly what can fly and cannot fly, or ideally not fly, in the MR chamber. I'm not sure kind of in terms of manufacturers who could be able to provide that. I think the one we have is custom made. I might be wrong, but I think the one that we have, for instance, is also only tracking one eye. So that's something to keep in mind. I know the researchers use it to kind of monitor task compliance within the scanner. We do a lot of fMRI, where we're looking at a, how do you say, task-based cognition. So it's that in that case is mostly for that rather than an interactive eye tracking task like Ana Maria mentioned, where that is the goal in itself. I know it has been done, especially with one of the paradigms that I used. There's a study, which actually is not that new, that had a very similar task, which is kind of a visual gaze, to notice disengaging gaze from one side to the other and trying to kind of understand the kind of underlying mechanisms at a brain level. So definitely doable. But yeah, my best thing would be like get in touch with your MR technician, safety protocols, and work together with them to see kind of what are the requirements and what you can get in the scanner.
Good, thank you, Monica. Then we have a question from Gibin. I have been working with first-year engineering students who use eye tracking when they are taking a test, but most of the time their pupil movements are so fast. How to process this data? Maybe Maya, do you have any a reflection on that, or do we need more information from Gibin?
I think I missed the last part of the question. What did you say?
Yeah, if we have any, how do we process data? He says that he's recording students using eye tracking when taking a test, but most of the time their pupil movements are so fast. So how do we process this data?
Right. So I guess the question would be, like, are you referring to gaze movement or a pupil dilation? Because pupil dilation is often not that fast. But when we look at pupil dilation, we also often take a mean out of a longer measurement window to also account for measurement error and so on, because it can be when you blink and so on, the pupil can seem to switch quite a lot. But if you're referring to actually gaze patterns when doing a test, I guess it's also back to what Monica was saying, that you need a sufficiently accurate eye tracker to be able to detect these small and quick movements as well. But I'm not sure that I'm really answering the questions.
Yeah, I think we are tapping into what how we can help here. But maybe if you can specify a bit more your question, then we can probably get better on that. But definitely, what is really the metric that you want to look at? If we understand that, then we can give some recommendations on how to process the data.
I think one thing that, sorry, one thing that we can add, eye movements, as Maya said, pupil dilation is very different than, small locomotor changes, like in terms that we usually say that is fixation and saccades, but they are usually short. Their nature is very short. So if you compare, for example, with even fMRI, I think Monica will be able to confirm this. The time structure and the time scale of fMRI is not as precise as eye tracking or other imaging, or even other imaging methods. So when you want, or even some tasks, if you are just, I don't know how fast reading movements are, but but like if depending on what you are, what is your parallel question or your parallel method, you might need to think about how these scales synchronize with each other to be able to get the most out of your eye tracking data or your fMRI data or your task.
Yeah.
Yeah, of course. There's a huge delay. I mean, the bold response in itself is slower. That has to be taken into account. So yeah, you have to work in, as I think Maya said it, it looks very easy, but not. And also, I will not be the first and most certainly not the last person to say that integrating different technologies is a challenge in itself. So yeah, but I mean, that being said, I guess grit and being very much aware, as Ana Maria said, like what the challenges you're facing. You're looking different scales, you're maybe quality, everything that can kind of infiltrate your study, that is kind of, your signal to noise ratio. What is actually your signal and what could be noise, and how you mitigate it or account for it. Like maybe you can't do anything about a lag, but if you know it's there, that makes a huge difference in terms that you can actually kind of, it won't be perfect, but you can say much more that if you had no idea that this was happening.
Yeah. Yes, great recommendations here as well. We go on to the next question from Kristen. She says, I have 2 questions. I'm looking at receptive language, specifically word understanding in nonverbal children with autism. From what I've read, there is a lot of missing or unusable data with this population due to movement and sometimes difficulty calibrating. Could anyone speak to this or give advice on how to avoid this? Is there eye tracking equipment that can be used in the natural environment to look at eye gaze between a child and a caregiver in a play-based activity like playing on the floor with toys? I think like the first question about missing data, unusable data, maybe Maya, you want to answer that? You're our language expert here as well.
I don't know if the question was specifically language based, but it seems like very interesting research and very important research that and I think the question really pinpoints an issue that we have in autism research. It's that there's a huge part of the population, the autistic population, that we seldomly reach in our studies because of exactly what you say, that it can be difficult to collect data and to have valid enough data, and I'm not certain I would be the right person to answer what to do about it, but I'm thinking there's some issues pertaining to participants that are fussy or have very short attention spans or get very stressed in specific situations and so on. And I think it's very important that we don't shy away from attempting to do these studies anyway, and then try to adapt the way we conduct the studies, the stimuli, the questions we're answering, but also maybe accepting that we have less data and it might be more preliminary, but at least we start to understand it anyway, because like receptive language and word understanding and minimally pre-verbal children is an extremely important subject for us to understand.
And I think as a field, like the kind of research you're doing is important and like very important. And I think if anything, it speaks to everyone that we need to be kind of receptive to kind of as much progress as it can be done, you know, like, and maybe in that case, and I think it's what Maya was also saying, spending more time in protocol development, piloting, you know, a lot of the times, you know, you just want to jump into it. And maybe if you have an adult population that is, you know, college students, psychology's favorite, then you might kind of spend less time on that. But even with adults that are kind of sensitive or kind of on the spectrum, then you might want to spend, you know, manage expectations. And I mean, maybe you're in a tricky position, and this is not kind of to discourage, but you need a good eye tracker to have those really small movements, but at the same time, having such a good eye tracker will allow less space for movement. Like it will capture more, be more sensitive to noise and whatnot. So it's probably a good idea to try to, you know, find the somewhat compromising balance. And I mean, we saw that with infants, like we could have a very powerful eye tracker, but there was a lot of head movement. So sometimes it was actually better to go with a lower sampling, right?
Mm-hmm.
But we had infants, once again, it was like not ballistic reading eye movement. So it's kind of.
But I mean, you are already in the right position, as Maya and Monica said. If you can change your protocol and make it more fun and attractive to your population, that's a very good step. And also, if you are aware of that lack of compliance and more noise, then you are in the right position to quantify that noise and that compliance, and then add that as a covariate in your analyses or a way to assess the robustness of your findings in a way that whatever you will report later on is robust to that kind of changes that are like super normal across these populations.
Mm.
And I guess a lot of the issues are also the same, that is like for using participants or studying participants that are pre-verbal in general. So maybe look into eye tracking studies on young infants and see what has been done, how to calibrate and how to design your experiment and so on.
You can also get a good idea by looking at the literature of what is like typical attrition rates, or like how much do we actually get, you know, like even if it's just a sanity check for you, like, okay, you know, this is normal, like, or I have to improve, or, you know, just getting some perspective, because it can feel daunting, like, oh my gosh, I'm losing a lot of data. So sometimes.
And as Monica said, have a compromise. I've done research with adults before going to the infant children world, and you need to adapt, and you need to like be aware that it won't be, you know, all the control variables that you have in an adult psychological or psychophysics experiment won't be there for the infant study. You have parents and pacifiers and snacks during your task, so you just need to be kind of open to that.
Yeah, great recommendations for Krista.
Yeah,
know your population and adapt to that, and also maybe going back what you said in the beginning, Anna Maria, with the gaze contingency to keep the interaction attention ongoing, so that we can ensure that we get a lot of data that we can use for an analysis. But talking about like a lot of things can happen during an eye tracking session. I remember like when infants started crying and they had tears in their eyes, and like that would affect like the data quality, or like it was so funny for them, so they were laughing and like tilting their head, and like then we also had missing data because of this. So there are a lot of unexpected things that can happen, and like also going back to what the panel has said before, like piloting is super important and will help you detect those behaviors that you maybe don't expect in the beginning.
Yeah, sometimes your task is just way too fun. I had that happen too. It was very surprising.
Yeah.
We had such an engaged infant that the data, I don't know, it just, it didn't reflect their enthusiasm for sure.
But you can also have children falling asleep in your protocol.
That is, yeah, that is the other side of that, which also happens.
Exactly. All right, but let's go to Kristen's second question. Is there eye tracking equipment that can be used in the natural environment to look at eye gaze between a child and a caregiver in a play-based activity, like playing on the floor with toys? And I know that Maya has something going on similar or knows about those studies.
No, I mean, it's what we all want. Like, no, it's not what we all want to study, but it's what I want to study too. It's such an interesting like situation. What is going on between two people, or with the caregiver and the child, and also in relation to language and so on. But I think it pertains back to the difficulty in so what I'm going to say is that I'm looking at, like Sheila said, on an experiment or a task where we have no screen. So we have a person that is acting or is interacting with the child, and then the child sits in the parent's lap, and then we can track the eye gaze of the infant or the child, and in that way we can get to a bit of the interactive aspect of their like visual behavior. But I'm not. I know there's been attempts of doing these kind of having two eye trackers and tracking two people at the same time. And I know there's a study there's a lab in the Netherlands. Do you know where? I'm not certain which university, but they are really forward in developing this. But I know they have also had issues with calibration and with actually like knowing exactly what the participants are looking at. So I'm not certain that we are in a position yet where we can have like a child and an adult in a quite free play situation and really be certain what we are measuring yet. But there's attempts towards that.
We need to wait for Tobii to develop wearable infant glasses.
Yes.
But
yes,
I mean, you can also have the baby on a high chair, and then you can put the parent where Maya said the experimenter was. It's just that the interaction with toy playing might not be so free because you need a tracker device in between them. Yeah. I think the lab that you are referring to, Maya, was Utrecht, maybe?
Yes, it's probably Utrecht, yeah.
I believe so too. So Kristen, we can get back to you and send you some papers of that group. I think we're all thinking about the Roy Hessels and Jonas Hoer.
Yes.
Yes. So yeah, then we get back to you. And
I mean, another option is always to use, like webcams, but then you don't get the preciseness and the robustness of or even the time scale of an eye tracker.
Yeah, and then you have to account also for human bias, which with the eye tracker you can remove to a certain extent.
Yeah, for sure.
Oh.
Yeah, so I see that our time is slowly running out. Let's see if we can answer some other questions as well. So Robin asks, does anyone have advice on using and analyzing pupil dilation as a processing cue? You sort of get the data for free with eye tracking. Any of you that would like to answer that question?
So yes, I have been using looking at pupil dilation, and I guess Anna, you have also done that. But I think I missed. It was a bit of a lag, so I think I missed just what the exact question was about it.
So does anyone have advice on using and analyzing pupil dilation as a processing cue? Maybe you want to describe how you are using pupil dilation in your studies, if you're using it currently?
Yeah, so one thing about pupil dilation that I think is important. So yeah, it's a great thing that you get it kind of for free when you're using an eye tracker, and I think that's amazing. And the pupil dilation is such a cool measure because it actually taps into a quite specific system in the brain pertaining to noradrenaline. And no, it doesn't, because we're looking at different measures, me and Anna. So I'm not going to say that, but it's one of the things that are affecting our pupil dilation is this noradrenaline system in the brain. And one important aspect of the pupil is that all of us have different pupil sizes, and they change a lot. So they change depending on the lighting and on things going on internally and so on. So what we have been doing is that we have measured pupil dilation as a response to something. So in the study I was conducting, we looked at responses to different sounds. So the infant heard a sound, and then we looked at pupil dilation shortly after that in comparison to the pupil dilation before. So we took into account the individual differences in pupil, tonic pupil. And I think that is a very important, you have to account for that in some way, because the absolute pupil dilation is not the relevant aspect, it's the difference. So I guess that's a tip, at least.
Yeah. I think what you are trying to say, Mai, is that you need a baseline before your response. So you need to have like a period of time that you know, like that you are referring your response to when measuring that. And also you need to be aware of your the temporal dynamics of your stimuli, because the pupil response is going to have a different scale than a gaze response. So if your trials are really, really short and fast, then it's likely that your pupil response will only appear a bit after, right, Maya? I remember you having like, you know, you kind of measured your pupil response in like 1 to 3 seconds or something after your stimuli, and that is quite different than what Monica was saying before about, you know, disengagement responses from stimuli, where your interval is like 200 milliseconds or something like that. So being aware of the structure of your task is important when defining these baselines and these response periods.
Yeah.
And also, you know, like light is important in the room, but also where the child or infant or adult is attending, like the stimuli that they are looking at will change. You know, the luminance and the brightness of that stimuli will change how their pupil is. So it doesn't, you need to control for a lot of variables in order to then assume that it's a cognitive, for example, effect or an arousal effect or only a environmental effect. I don't know. Yeah. I think there's a lot of controls, but you can always plot the data and see what you are getting.
Yeah, and I think I just want to add that even though you get it for free, it's quite seldom you can use the pupil dilation in a typical eye tracking paradigm. So if you're as Anna-Maria said, you have to have quite constant luminance, and you have to have quite specific. You have to have the participant actually focus on the screen, so you get the pupil, but you might not want to have very varying visual stimuli on the screen. So there's some specifics you need to account for, but it's a very interesting measure.
Yeah, it's a very interesting measure, and I mean, you can always measure how variable that measure is, and if you had controlled for the other, for like luminance and things like that, then that variance in pupil might be informative. I don't know.
Yes, great points. Thank you so much. And I see that we are already over our time. Time goes fast when we're having fun. We unfortunately have to close now, but thank you so much for all the questions. Those that we couldn't answer during this time, we will get back to you after the event. So you will get your question answered, of course. And feel free to reach out to our panel if you have any additional questions. We're here for you, and we are happy to help. So thank you so much for everyone joining our panel discussion. I'm so happy we got so many questions and interest from the audience. It's really nice to organize an interactive event and really tailor this session to the audience as well, and answer your questions. So thank you so much, Anna-Maria, Maya, and Monica. A special thank you to Monica, who joined at 7 a.m. and everyone else joining from the US. It's super early for you, I understand, but thank you so much for joining this panel. So on that, we close our session here. Thank you very much. Have a nice evening or have a nice day.